particularly useful in image and text classification problems. You have the ensemble method. So these advanced techniques are not just tools, they are responses to the challenges posed by real-world data. They help overcome issues like non-linearity, high dimensionality, and model variance. So mastering these techniques allow you to build more accurate, efficient, and robust machine learning models. Then we have the tree-based method like I talked about. So you have the decision tree, which are used for supervised learning algorithm. Predominantly used for classification problem. They work by breaking down a data set into smaller subsets while simultaneously developing an associated decision tree. So how does it work? Starting at the tree roots, data is split according to certain criteria. Then each internal node in the tree corresponds to a decision that splits the data, and each leaf node represents the classification or decision tree. So there are a whole lot of concepts behind it, right? So you just need to probably after the class go on and expand your knowledge about it. But there are some challenges and considerations. Despite the advantage, decision trees can be prone to overfitting, especially with very complex trees. So decision tree models lies in determining the right depth and complexity of the tree to ensure it generalizes well to new data. We have the random
Hello everyone. I don't know if you all can hear me, but I think that our host has some difficulties with his network, as all of us, I believe, I don't know, some of us. So, please let's exercise a little bit of patience. We are really sorry about this. Okay, so maybe when he comes back, you guys can discuss with him about how to reschedule, because your class today, as half of it has been taken over by network issues, technical issues. So you can have a discussion with him on how to reschedule. Hopefully, you'll be able to still have the class today or maybe some other day. But then the stage ends tomorrow. So I don't know how feasible that would be if it's not done today. Can we all hear me?
Yeah, we can hear you.
I can hear
Okay,
you.
all right. And
Yes, I can hear you.
yeah, and for those who we promised the other, what do they call them now? Notebooks. We haven't forgotten you. I'm just waiting for him to come back so that you'd be able to, yes, and he's back. So Dominion, please put it to him to remind him also.
Hello, can you guys hear me? Hello, can you guys hear me?
Yes, we
Hello,
can
can
hear you.
anyone hear me? Yes,
I
Yes,
okay.
can hear
please.
you.
Yes, we can.
I see my
So
screen, right?
yeah, good reach. We were discussing when you were away about maybe rescheduling until all of the live coding sessions today are over. I think that would
Okay.
be a good thing if they are, because half of their class has been overtaken by technical issues today. That's one. Second
Oh,
of all, please, right now, maybe you can help share the notebooks, please. Help share the notebooks. And then maybe I would copy and paste to those on YouTube. I don't know. Because Nina, I think she's having issues getting on Zoom as well.
okay. I'll just share the link with us. Give me a sec.
I'm talking about the first two notebooks.
Okay,
The very
okay.
second one,
Okay.
yeah. As well as today's own. I think they all got the one for last week. I'm sorry, for the past, yeah, for the last coding session you did.
The first one and the second one. That's it. The one and the two, then the two.
Yes.
Okay. Let me try and get that. Mm, okay, one.
You know
Yes, I'm
what?
trying
Just
to
share all
get
of the notebooks because I think Dominion is making a comment now about how it wasn't shared on YouTube. It can't be shared on YouTube. We already said this before. But I'm only trying to share on YouTube today because I know some people are also having technical issues as well. So we'll just share it briefly, have them copy it out, then after a while, get it off.
Okay, I'm dropping the one now.
Okay.
Let's go to- Okay, I'm dropping the two now. Then that of today, right? They already got your last one.
All four notebooks would be nice. That's what I said, including today's
Okay, the
one.
four of them. Okay. Let me just send the
Yeah.
three at once. Uh, mm, okay, I'm dropping the three now. Then today's one. I'm dropping the four. Today's one. Yeah, I think that's it.
Thank you so much. You have very limited time left, so begin and maybe reschedule for later today. I don't know if you can do that.
After all, what time today again?
Are you guys down for starting by 6 p.m.? Nobody is
I
speaking. It's all right. They might not need a
think
reschedule
they have
then.
the
Just
the.
okay.
I said they have the notebook, and I don't know. I will
Okay,
not
maybe
end up
just
maybe
do brief,
someone will come.
yeah, very brief run through.
I think that will be fine. You just run through, then we follow through
Yeah.
with the notebooks.
Okay.
Like now, before we end it,
Yeah.
right?
Yes.
Okay. Okay. Right. Let me just share my screen. Can you see the notebook?
Yes. You just zoom it.
Okay. Yeah, I'll do that. All right. So the notebook is it's basically it's towards the down the side that you see the whole model of a thing, but it's very detailed and it's about the Titanic data set which we've all heard about. That's what the data set we're working with is here. All right, so the problem statement is to predict people that survived and people that did not survive. That's the survival rates. Then, okay, so this is where we import the libraries, the necessary libraries we need, NumPy, pandas, our visualization library, then the whole, because I told us that there are a lot of classifiers out there, right? So this is basically me bringing in a lot of them, and we're just going to see how to probably look through them and get accuracy, and then from there we enhance the ones that the accuracy is actually high. So let me just be running that just in case I have to run somewhere. We have just 10 minutes. All right, so this is me loading in the data sets. I think I should drop the link to this data set because you guys don't have access to it. Just give me a sec.
Yeah.
Let me do that. So it's actually the Titanic data set on Cargo. That's the one I'm using. So I'm going to drop it now on the platform. So that's where the data set is. Okay, I've done that. All right, so okay, I'm just going to quickly run through it. All right, we load the data set. This is just us going through the contents, then a brief summary, then some statistical analysis, the type of variable. We have some features in that data set that are categorical, like the name, the sex, the cabin, right? The embark. So these are stuff we also need to handle. Then it's split into training and test, just so you know. We have the training and test differently. Then what else? After that, we are just looking at the data set at this point, just going through the training section and then the test data set too. Then looking at some statistics about it. Then here is actually where we do some exploratory data analysis on each of the features we have. So this is survived feature. You see that it's imbalanced at first glance. So people that survived are actually few than those that did not survive. Okay. 549 people survived. Because the people that died are actually one. People that survived are actually zero. Please take note of that. Then this is where I use Plotly to just visualize that those that did not survive, those that survived. So I think this taking is wrong. Zero stands for not survive, one stands for survive. So 549 people did not survive. Why 375 people survived? Okay, I'm just going to sketch. All right, so we just plot that. We have the looking at it by the female and male. This is just a breakdown into female and male. You see that female has more probability of female has more probability of surviving, right? To survive the most. Then we split it into okay, what else is here? This is me looking at the percentage of those that survive, right? That are males. This one is the ones that are female. What is happening here? I think it's the same thing. So in the male category, those that survived and those that did not survive. This is for the female. Percentage of those that survive, those that did not survive. Then in the male section, those that survive is actually those that survive is actually 18% of all the men. 18% survived. 81% did not survive. This is distribution of sex. We have yeah, we've seen this already. 507 male, 314 females. Percentage distribution among passengers. Okay, this is just that stuff in percentage from P class. Yeah, the distribution of the P class. This is by survived. Let me just go down. It's actually a long notebook. This is where we did some. Okay, let me just explain data processing. So we removed the ticket and passenger ID because it's irrelevant, like it's not going to add anything to our model. Then we did some feature engineering. We tried to get those after Mr. and Mrs. It's like feature engineering in this aspect. Created a column for that. But we actually made use of that column to fill in the missing values that was in the age. Under the age column, there are missing values. I don't want to scroll back up, but there's a missing value in the age. So what we did was to use the title Mr. and Mrs. Right? So if it is Mr., let's say it's a man, that's Mr. What we did was to look at the median for those section of people and fill in the missing values for those that are Mr. Then those that are Miss, those kind of stuff. We did that same thing. Those that are either neither Mr. or Mrs. We also look at the median in those category and then fill in the missing value. That's what is happening there. Then we removed after using that title to do that, we took it down. Missing value in the cabin. It's more like optional stuff. We make use of the first letter. Then those that do not have anything, we replace it with unknown. Then what did we do here? In back, we just fill in the missing value with S. Then after that, we take the missing value. There's still one under face, so we just fill it with the median. Then there's outlier in some of the pictures. That's age and found fair. Look at it. There are outliers. There are outliers in these two features. So what we did was to do interquartile range to, replace all those that are outliers with the maximum value of that column. That's what is happening here, right? So wherever in that row there's a outlier that is above the interquartile range, that is the upper boundary, it's just going to replace it with the upper boundary. That's what is going on there. Then from feature engineering, we have male and female in the gender. Is it gender we have there? In the sex category. So what we did was, okay, we decided that anybody that is less than 16, we classify them as child, so that we have the male, the female, and sorry, we have is it male? Please give me a second. I need to go. Okay, I don't want to be running around. Well, we divided into three. So we have the male, the female, and then the children on board. What else did we do? This is just looking at the plots using the plots. Looking at the distribution by class. Yeah, we decided to check those that are traveling alone using two of these features. This one is parent and child, this one is siblings. So if after joining these two columns, it's not less than, it's not above zero, that means the person traveled. If it's above zero, that means don't bounce me out. Not again. I'm tired. I'm tired. I'm tired. I'm tired. I'm tired. I'm tired. Microsoft. How? Why they play the Hello? Sorry, the stuff bring me back in. Hello? Hello, can you
I
guys hear me?
Yes, we can.
Yes.
Okay. I thought
Yes,
the
we can
network
hear
was
you.
going out again. Okay, sorry about that. All right. Um, this is okay, the alone section. All right, let me just scroll down to the correlation between the features and the targets. We can see this. They have negative relation, they have the positive relationship. is the what is it called? The heat map showing that. Then we have the categorical. This is actually where we start doing the whole encoding of everything. So for columns that are categorical, we decide to, turn it to numbers. We drop the sex since we've now then created a person column that has the male, female, and the child. So that's why we drop it here. Then what did we do here? The alone, inside the alone, we have the ones that's this people that has family and those that traveled alone. That's like another feature. So we replace those with family with just numbers, zero alone as from both in the training and the test data set. Then we use the label encoder to do the other ones for embark, deck, and person. So you can see that it's all numbers. The next thing we are going to do is to normalize the data set. So we use feature scaling to scale this age and which other one and fair. This one and this one. You can see that the numbers are just like not on the same unit. So we use feature scaling to scale it. That's what is happening here. Then this is where we split the data into training and testing. That's 7% and 33%. This is 7% and 33%. Then this is actually where we list out all those classifiers models we brought in. Right. There are a lot of them, so I just list them in here. This is it in list with some necessary parameters that it needs to perform well. Then what is happening here is we are looking through each of them and we are retrieving the accuracy score for each of them. Just I know at this point we are just splitting and training. We've not done anything like hyperparameter tuning and the rest of them. So at this level, this is what the score looks like for each of those classification models. So it's at this point that you can decide, okay, since this guy is doing better, you can just go on to use this model and do your prediction. Right. What you just need to do is just pick out this one, then do some hyperparameter tuning on it so that you can have more better results. But yes, this is it. Looking through and getting the results for each of those model. Then this is the accuracy score, just in a tabular form. What did we do here? Sorted by descending order. So this is one that is giving us the highest score, followed by neural network, then Ada boost. Then yeah, just in the charts. Feature selection, we use random forest to do feature selection. At the end of it all, we saw that some feature was good for the prediction, which is on person fair age, right? Then we visualize it. This is what it looks like. So this one is not really giving us, it's not really helping in the whole prediction, right? So you're likely going to drop it, which we did here. So we dropped the least important feature. Then we went look through again, and this is what the result looked like this time around. So this is the first score, this is the second score. So we saw that after dropping that alone column, some scores reduced, some score increased. Look at the k neighbors, nearest neighbors. It was 0.7, but after dropping it, it increased, right? But yeah, this is the first score, this is the second score. Then confusion matrix to explain the prediction that it did. That's for the Gaussian. So that's just some details. True positive, the ones it treated correctly, and the one that it misclassified. What else did we do here? The error from the accuracy. This is just explanation of the metrics. We've already gone through this in our second class. Cross validation. We did cross validation for each of them. You know what cross validation does? It's like sectioning it and um, the data into different sections. This is what the result looks like after the conversion. So we decided to go with the top three performing model, right? So done well, we can then pick it. So this is us trying to do some parameter tuning. So you should also know that you could you could tune your model, and you probably know
All right, guys, Bruno, you don't have to feel like you're wasting your time. However, your tutor, I don't think is going to return here. Is done for today, and just try and look at the notebook. I hope you understand the notebook. All right, that'll be the end of class for today, so that we'll give in space for another track to begin their own live coding session. Bye bye, everybody.